Willkommen, bienvenue, and welcome back to the Modding of Isaac with Lyte. Today's episode is on custom enemy AI. Totally from the ground up, none inherited from the game itself. Now, we are using the animations that were provided to us. We are not creating something totally new here, but we are writing the AI from scratch. We're using Dingle because everyone's familiar with Dingle, what Dingle does, and when we make modifications to it, you'll recognize anything that does go a little differently. So we're just going to get right into it. Another fairly sizable episode. Gotta get started. So step one, we need to spawn one in. 700.0 Magidingle. He couldn't afford a fancy wizard's hat, so he just painted his head blue. Now he charges you, a random number of times. So it's not always, he throws fire. What else can he do? Oh, he can teleport and then throw some more fire. Positioning is a little off, so I might want to fix that a little for when he throws the fire. Oh, come on. Whistle! Whistle, you jerk. Whistle! The trouble is, his attacks are, random, so you don't know which one's coming next. He telegraphs them a bit, but knowing which one comes next is a little rough. But hey, he's a necromancer. He can summon bonies. So we've seen all the various things that Magidingle can do. All of this AI was written from scratch. None of it was inherited. So let's take a look at the code, get you making an enemy like this yourself. Step one, as always, entities2.xml. This is where you make your entities exist, whether they're enemies, pickups, tiers, anything, they're all in here. This is in your content folder, as always, and a lot of it you can take from something that already exists. For this, we use Dingle, but you pick whatever's the most similar to what you're trying to make. So Dingle gives you a lot of this information that we didn't change at all. Their HP, their stage HP, their status of being abolished, all of that is the same. Change the name, of course. The anim2 path, we made this anim2 file, it's in GFX. The ID and the variant. You have to hard code these, unfortunately, but it does make a little sense. Because if you've got multiple variants of the same enemy, well, if you don't put an ID in, it has no way of knowing that they're variants of the same thing and not two different things. Another thing, you have to use an ID less than 1,000 if you want your enemy to have collision. Because at 1,000, it becomes an effect, and effects don't have collision. No matter what collision you set for them, it just doesn't interact. So you have to have an ID that's random, below 1,000, but above the largest number for an actual entity that comes with the game. So, yeah, that is a little tricky, because even in the documentation, they don't have all of the enemies. So here's the Luidox. You've got Little Horn and Ragman and Ultra Greed and Hush, but you don't have the Sisters Vis in here. You don't have Rag Mega in here. So, I mean, somewhere between 500 and 1,000 is fairly safe. They've used up about half of the space, half of it's left for the rest of us. It's a little rough. So you might end up wanting to just take one enemy entity space for yourself and just add a bunch of variants. I don't know. It's a tricky situation with such a large community but so little space to make things. But you set your ID, you set your variant, you set your subtype, and also I've added a little bit in here down at the bottom for preloading sounds that we're going to use for this different version. So you just look in the Luidox or the sounds.xml for the ID number for the sound you want. And then I added a little bit of comments here just so you know this is the fire death hiss, the kss when the fire is fired. And then Hell Portal 1 is that zoop for when they teleport. Preloading is good practice. It's not strictly necessary, but it's a good plan. So that's entities2.xml. Next, we're going to head over to the animation editor. We're going to look at this magidingle.anim2 and see what's going on there, because this is crucial to the way this AI works. So here we've got the idle animation. He just bobs up and down. Only a couple of frames long. It gets used over and over and over again. Normally, this would be looped. So when you get this animation from Dingle, it's looped. But I unchecked loop because the way I'm going to show you to do the random AI, it's crucial that it sees how the animation ends. So it sees the end of the animation. When you hit loop, there is no end. It just keeps going. You would need some other way of tracking when to make it end, and that will get you into a bit of trouble. Then all of these other ones come with Dingle, except Teleport here at the bottom. Teleport I made myself, more or less. I stole the first half from before Slide, where he's just breathing in, he's scrunching himself down, and he's getting ready to pounce. So for Teleport, he does the same thing, he scrunches down, but in the scrunching, he squeezes together. So if you look up in this middle bar here, the scale is what's changing. So it starts at 100, but goes to 90, 110, and then 80, 120, 60, 140, 40, 160, 20, 180, and then 0, 200, and poof, he's gone. He's gone for a handful of frames, and then he reappears, reversing the order of everything that came before. To add a frame, you just go to the last frame where you want to add it, you hit Insert Frame at the bottom, whoop, and you now have a frame. If you want that frame to last longer, you can add duration to it. Say in this frame we wanted to make him really big. 200 by 200. Really big. Then we come after that, we make another frame, and he's back to normal. So he's really big for a while, and then suddenly he's really normal. Oop. Well, what if you didn't want him to go really big, suddenly really normal? Well, then you hit Interpolated. And that takes this big long thing and makes him gently scale in a linear fashion from where he was to where you want him to be. So if you don't want all the hard work of doing the scaling or the bouncing or the something, you can interpolate it such that it has a nice smooth transition from where it is to where it goes. But again, it doesn't know anything about animation. So if you're moving from one thing to another and you want to deform it in a nice, fantastic way, make the frames yourself. If you need to delete a frame, you just click on it and hit delete. Poof, they're gone. Other sorts of things that you've got here, the crop X and crop Y are identifying where in your sprite sheet you should look for the content. Width and height is the size of the thing you're grabbing. Position X and Y is in the animation pane on the left where they're positioned. The pivot is their relationship to 0, 0. And then the scale I've shown. The rotation is in degrees, so if you change it to 90, they're on their side. Other than that, you just tinker around with it and you'll see what it does. But we're missing the most important part of working with the animation editor for AI. It's these events down at the bottom. You can see there's a triggers bar across the bottom here. Well, that lets you actually say, at this frame, you should teleport. If you go over to whistle, there are two of them. Frame 5, you whistle. At frame 17, you spawn. Now, the original Dingle file only had spawn. I added whistle because I wanted to. I want to have this tell me when to start the whistle. What this does is it lets you separate the process such that you can have an animator working with the imagery and set up when things should happen, down to the frame, without knowing anything about how the code makes it happen. And then the coder can actually make those things happen without knowing anything about the animation. You don't need to know how long it is. You don't need to know when in the animation anything happens. You rely on your animator to provide these triggers, and then you can work completely separately. And If those two people happen to be the same person, you can just separate the work, such that you don't have to recode it if you decide, maybe we should make this delay a little longer. Maybe we should fire twice during this, thrice during this animation. You can change the animation without changing the code. And then if you change how you want to get something accomplished, you can change the code without changing the animation. It's a great way to separate things. So everything I'm going to show you is based on animations, how long they last, catching when they end to transition to a new state, and catching the triggers for when you actually do certain actions. So let's head back over to the code. We're about 10 minutes in, and we're actually going to look in the main.lua and see how we do all of those things. Now, what I'm going to show you first is the guts of making the states and working with states. We're going to skip the first bit here with the Markov chain. We'll come back to that. We'll come back to the transitions. But it's mostly about states. So we start off our mod as usual. First line, register the mod. Second line, sound effects. If your enemy is silent, they're so hard to react to. They're really unnerving when they make no sounds at all. You know what I mean if you've ever played Minecraft back when witches were silent. You didn't know a witch was there till you got hit with the potion. Always have sound. Entity type, Magidingle. Get entity type by name, as we've done many times before. Then we set up an enumeration for the different states that our Magidingle can be in. They can be appearing. It's the default. That's what happens when they first are spawned. Idling is them just sitting there bouncing a little. Pre-slide is them getting ready. Sliding is them actually trying to get you. Tired is them exhausted afterwards. Dance is their pre-spit little dance. Then they spit at you. The whistling just happens. And teleportation is my fancy new state that has them zoop somewhere else right behind you. So we enumerate those states such that later we can work with them. So this entity type by name thing, this addition to the enumeration is only used once. It's all the way at the bottom where we add the callback. So NPC update callback, sending it to this function, Magidingle update, filtered by only Magidingles. Only Magidingles act like this, so you filter it using this value, which is constant, hence the capitals, and we get it by name. So we don't need to know that it's number 700 in the code. So this Magidingle update function is run every frame for the updating of what Magidingle wants to do. Step one, we get the data. This is user data that we attach to every Magidingle, and then we get the state and the state frame. If they are nil, we set them to 0. The initial state is 0. They start the frame at 0. You might be thinking, but Lyte, NPCs have a state variable. You showed that with the dingle that did nothing but charge. And I did. But it doesn't work unless it's a variant of something with AI. And I've worked with this trying to get it to work with the inbuilt state variable, but I set it to state 1, it sets itself back to state 0. It's really frustrating. So you can't use the inbuilt state and state frame unless something changes, or if I'm just a ridiculous idiot and something went totally wrong. But for now, we'll use get data and we'll save our state and our state frame in there because we know that works. Then we get local target. This target is the entity get player target. Always use get player target. Don't use player as get player 0. Because there might be a punching bag on the floor and you need to figure out who to actually attack. And it's not worth it to go, oh, well, if they've got punching bag, then check for entity punching bag and send them after. No, because that's not how punching bag works. Punching bag sometimes is you, sometimes is the punching bag. If you've got several punching bags, it's just too much to keep track of. So just use get player target and you'll be set. You'll be good to go. Even if someone comes up with another thing that isn't punching bag but acts like punching bag, it'll still be good. Then we have data state frame equals state frame plus 1 because we increment it every frame. You can do this here Or you can do it at the end down here. But you have to be consistent with which one you do and know whether or not the initialization of a state will result in state 0 or in state 1. And where it'll happen, it's just pick a place and do it. So then we've got a big old if and a bunch of else ifs. You can see that these are a bit scrunched down for the sake of seeing it. One for each state that your Magidingle could be in. All of these take a very similar course. So we're going to open up idle and see what happens there in a moment. But first we have appear, because appear is default state. When you summon them in, they're appearing. Their animation is the appear animation. So once, I think, haven't necessarily tested this one enough, but if they're in state 0 and the appear animation is not still playing, then you transition to the idle state, and we set the frame to 0. So that's all we're doing here, checking if they've appeared. If they're done appearing, you switch over to idle, and always set the state frame to be 0 when you start a state, such that you know, okay, I just started that state. So now we're in idle, and so then next frame comes along, and we get to this else if, because we're not appearing, we're in fact idling. We'll open this up. If the state frame is 1, because it was 0, we added 1. Hey, it's 1. If we just started idling, then we play the animation. So entity, get sprite, play, idle. Now, you could take this and make it another local. Call it sprite, and then do sprite play. It might save you some spelling errors. We all hate those mundane little details, don't we? And then this true, I don't know if it really needs to be true. This is for forcing the animation. I don't think you really need it to be, but I'm doing it just in case. So we just started being idle, we play the idle animation. Okay? If it didn't just start, then we check whether or not it's done. So get sprite is finished, idle. So we're probably saving quite a few characters if we changed this to just sprite up here. Sometimes I'm not the most efficient. So if it's finished, then we transition from idle, either back to idle or to something else. But we always set the state frame to be 0 because we're going to be starting some state, even if it's idle again. If you want your enemy to be completely predictable, you don't need this Markov transition function. You don't need something random. You just say, after you're done idling, shoot. So you change the state to state shoot. And then when you're done shooting, you go back to idling. Or you always randomly walk for a little bit, and then you fire, and then you randomly walk, and then you fire. If it's totally deterministic, you don't need this random function. You just say, progress to state whatever, and then move on with your life. But if you want it to be random, like this dingle is, stick around for that Markov transition. Otherwise, you're more or less done, because all of these other states are going to be initialize, see if you're finished, or in the case of something like slide, you check if an event is triggered. So if it just started, initialize it. If the event is triggered, so entity get sprite is event triggered, slide. So that was the trigger that we had down here. Granted, this is whistle. Let's go over to slide. So here on frame 5, you actually start sliding. And so you get it in the code here. If the event is triggered, then you slide. In this case, you take the velocity and set it to be your position versus the target's position. You normalize it down to 1, multiply it by 16. So this is a vector pointing from Magidingle to the player of length 16. That's velocity. That's how he gets the oomph to go as fast as he goes. And it's just an initial push. He doesn't need several frames of this. It's just when they say slide, you just shove him along. The friction will slow him down a little bit as he goes for a nice natural movement. And then when it's finished, you transition. And that's all there is to it. You play sounds when you need them. So sound, play, sound effect. Fart gurg is the sound that it makes. Again, you've got extra parameters here. I think it's volume. Yeah, I know the first one's volume. I know the third one is loop. Let's check out sound effects manager, play. So you got the sound effect, you got the volume. Oh, the frame delay. Do you want it to be immediate or do you want to delay it? Do you want to loop it? And then the pitch, 1 is normal, 2 is sharp, 0.5 is flat. You can move it up and down and that changes the speed as well. So you play the sounds when appropriate. So this is on initialization. There are other ones like with spit where you play the sound when it triggers shoot. So when it shoots, you spawn the fire, which is projectile 2. The fire hiss is the sound effect for it, the whistle has 2 of them. So if, else if, else if, else if. So when you arrive, you play the whistle animation. When it triggers the whistle, you play the whistle sound. When it triggers the spawning, that's when you make the bony. So we have the spawn position, get free near position, is where Magic Dingle is, plus a little bit down for a good place to put the bony. You spawn the bony, you play a fart noise. When you're done whistling, you transition. Teleporting, a little more complicated with figuring out where to put them. You take the player position, you get a vector from Magic Dingle to the player, normalize it and multiply it by 80 to get a little bit on the other side of the player from where Magic Dingle used to be. You set the position, you play the zoop sound. If it's done teleporting, you transition. Dancing, super easy. Nothing but arriving and transitioning. Same with pre-slide, you arrive and you transition. What else is closed? Tired, also, you arrive, you transition. Nothing fancy, except it takes the velocity every frame and decreases it by a bit. This gives it a nice, gentle stop instead of stopping on a dime, which is really abrupt. Every frame reduces it by a little bit. So there's the logic for doing each of the things that is done. Like I said, if you have a deterministic method where it goes from one state to another, to another, to another, always the same way every time, all you do is set the state here directly. If you want it to be random, stick around. We're going to talk about Markov chains. And down here, you got to face the right direction. If the velocity.x is greater than 0, you flip, because you don't want Dingle always facing to the left. If Dingle should be going to the right, face him to the right. It's an easy thing to forget. So that's all the logic for actually doing the things. Now we need to figure out how to do the transitions. So first off, we've got this Markov Transition function. It takes the state you're in, because a Markov chain is basically moving from state to state, but it only cares about where you are, not where you've been. So sure, you might have been idling and then shooting and then summoning, and then you're like, where do I go from here? Do I go back to idling? Well, sure, you go back to idling. Once you're in idling, do you care that you just shot or that you just summoned? No. It's a random thing going from idle to any of the other attacks. So that's what Markov chains do. They take the current state and move to a different state depending on where you currently are. Because it is important where you are. You can't go from charging to teleporting. You can't go from spitting to whistling. It just doesn't work like that. You have to go back to idle. You need to give the player time to breathe. So you get the state, you roll a die between 0 and 1. I know that's not really a die, but you roll up a floating point number between 0 and 1, because it's a probability you're working with here. It's always between 0 and 1. I know you want to be between 0 and 100%. It's between 0 and 1. 50% is 0.5. It's just mathematically the way it's done. Do it the mathematical way, because the programmers that made all of this stuff, they followed those math rules. So between 0 and 1, for I is 1 to the number of things in our Markov chain. So this is the number of states. You go through each one and you subtract the probability of going from the state you're in to the state you're looking at from the roll. And if it becomes 0, that's the state you're going to. So let's say state 1 is the state you're in. And you're deciding, Do I stay in state 1, or do I move to state 2, or 3, or 4, or 5? So the probability of staying in state 1 is 50%. Half the time, you stay in state 1. So we roll our floating point number. We roll 0.12789. Totally random. Well, that's less than 0.5. So when we subtract 0.5 from it, we get a number that is less than 0. So, we return state 1. We stay in state 1. Same thing. We're still in state 1. Let's decide if we leave again. We roll a 0.8. Ooh, 0.8 is bigger than 0.5. So 0.8 minus 0.5 is 0.3. Ooh, well, we've still got some space left. So we're not going back to state 1. We check state 2. State 2, there's a 20% chance of going to state 2. Ooh, 30 minus 2. Ooh, yeah, 0.3 minus 0.2 is still 0.1. We're not going to state 2. And then state 3 is another 20%. Ooh, okay, so minus 0.2, we're now negative. We go into state 3. That's how this function works. You should never, ever get to this last line unless you set it up wrong. This loop should always get below 0. But just in case somehow you put something wrong in your initialization, you need to return something. You can choose to return the first state, the last state. You need to return something. You should never get here, but it's good practice in case you do. I return the last one. It doesn't really matter. You go to the safest state. I think teleport's fun in case I do screw up the Markov chain. So that's this function. Very simple weighted randomness function. You give it the state, it rolls a die, it uses a probability of going from the current state to the state you want to go to, returns where it decided you should go. So all that's left is the configuration. And here we are. It's a table of all of the transition probabilities. So on the left here, we've got each of the states. This is the state that you're coming from. So this state here that you passed in is this state here. So you started in idle. You decide, what are my odds of going back to idle? 80%. It's a very short animation. You want it to run several times. So you have an 80% chance of going right back into idle. A 5% chance of going into pre-slide. No chance of going into slide, no chance of going into tired. You can't go from idle to tired. Just doesn't make any sense. And you got dance. Can't go into spit, you have to dance first. Whistle or teleport. So it's a complete box. Every row adds up to 1. What I was talking about with configuring it improperly, these need to add to 1 because that's how probabilities work. If all of the choices are accounted for, the total probability of doing whatever's possible is 1. Sorry about my voice, still got a little bit of phlegm. So it always adds to 1. Whether it's 8% plus 5 plus 5 plus 5 plus 5, or 1 plus a bunch of zeros. 0.6.4, 0.6.4, ones and zeros, 0.25, 4 times. Always adds up to 1. And you'll notice down here on teleport, you can't go back to idle from teleporting. You sneak up behind them, and then you either start to slide, you start to shoot, you whistle, or you teleport again. So why do we do this? This gives you a nice, unpredictable feel to your enemy in a way that's highly configurable. Without having to delve into all of this code in the nitty-gritty of how you implement each state, you can still configure how it moves from state to state. Certain ones you don't really need necessarily to split them up. Like dancing and spitting don't really need to be 2 separate states. They don't need to be 2 separate animations. But they are. And sometimes that's better for the animator. You might decide to have dance sometimes go to spit and sometimes go to whistle. That might be how Dingle works. I didn't investigate him too closely. Pre-slide, slide, and tired are nicely split because the pre-slide happens once. But then when you slide, you might slide again. and again and again and again, and then become tired. And then once you're tired, I made it such that the tired length is different. Sometimes tired goes back into tired, sometimes it goes back to idle. But later on, when you're playing with your entity, trying to balance it and everything, you might realize this isn't really working out for me because they're not idle long enough. Well, okay, now it's going to idle longer, but you need to subtract some from each of the other values if you want it to still add up to 1. So you then go, okay, so what do we remove? Well, we should probably remove a bit from the sliding because the sliding is a mite overpowered. So we might even want to put that down to 01. The shooting is really quite fun. We'll leave that how it is. So we've got 0.4 left, so let's go, or 0.04. So let's go like that. So we've got 5 plus 4 plus 1 is 10 plus 90 is 100%. That's how much it takes to rebalance it such that he idles longer, charges less, shoots about the same, but does the whistle and teleport less as well. Without having to go into how they're actually implemented down here. Because when you come back to an enemy a couple of months down the line, you might not remember all of the details that go into all of this. So you want to keep the configuration separate. And even more importantly, you're not going to be the only one configuring this. When people download your mod, they might want to change it. They might want to make it easier. They might want to make it harder. So keeping your configuration details separate helps everyone, especially yourself, but everyone. Same thing goes with separating the states out such that they work with the animations. You can trigger the transitions without knowing how long the animation is. You can trigger the events without knowing when in the animation they happen. You separate out all of these tasks to make your life and everyone else's life easier in the long run. Again, if you want a deterministic enemy, take out the Markov transition. You don't need it. You just set the state to the next state. But if you want it to be nice and random, this is a highly configurable way of doing it. We're about 30-some minutes in. We've covered all of these serious details. If you've got a particular AI function that you're not sure how it works, if you're not clear on how to separate out your ideas into these discrete states, if you're completely baffled by Markov chains, feel free to leave comments down in the description. But even better than that, if you go over to my Discord, there's a link down in the description. There are people there who are happy to help. I'm very often there and happy to help, and it gets more instantaneous and clear feedback than trying to do it down in the comments section. Comments are nice for just quick little questions, but if you need to share your code, it's usually better over in Discord. That's all I've got for this episode. I will see you in the next episode of the Modding of Isaac with Lyte.